What you see here is a clean room. It's located in the 35 National Center in the UK. This is only the national laboratory in the UK. They have the comprehensive facilities which can meet all the requirements for the device fabrication. The new idea is based on all the facilities which are available to the standard optoelectronics industry. So therefore, in order to make this Seren device, you do not need extra investment. All of the facility required for this idea has been available. So this machine is quite standard. Only this process step a little bit different.
What TAO has done is to come up with a very cost-effective means of building high brightness LEDs that are typically 2 to 3 times brighter than the sort of standard products you can get today. The high brightness LED is basically a quantum device, and you generate light in there by creating what's called an electron-hole pair. Well, TAO has been able to introduce some nanotechnology into that enables light to be created by a different channel. So you have 2 routes now in which your applied voltage can be converted into light. Sheffield is very privileged in having the UK's National 3.5 Research Centre, the only one of its kind in the UK, and all of the research activities behind this idea have been generated within that building, all the way from what's called the foundry process, where you're actually growing these semiconductor materials, right through to making the very basic prototypes.
In order to achieve the white LED, you have the 2 colors at least. One is the blue, another one is yellow. The key element is the blue light emitting diode. And this market obviously is huge because anyone have to use this light bulb for the general illumination. In the moment, we have already demonstrated this prototype. And in order to achieve the final product, there are 3 steps. The first step we call the epi wafer growth, and the second step we call the device fabrication. The last step we call the device packaging. Here is the second step, which is for the device fabrication. In order to carry out the device fabrication, you need a number of facilities. That machine is called the thermal evaporator. In order to make the device, you have to make the electrode. That machine can deposit this metal, and eventually this metal can become this electrode. You have to increase the temperature to the high to let this metal melting, and then you can evaporate this metal, and eventually this metal can come to on the surface of the semiconductor. That is a thermal evaporator. That machine called this RTA, which stands for this rapid thermal annealing. That machine is used for fabrication of the electrode. That machine is called the plasma enhanced chemical vapor deposition. Normally, device fabrication involves a number of steps. One of the steps you have to use we call the dielectric material. In order to deposit the dielectric material on the surface of the device, you have to use they call this plasma enhanced chemical vapor deposition. That machine can deposit silicon dioxide or the silicon nitride, both as the mask for this specific device here. The device fabrication also requires a number of we call the drive etching steps. There are 2 kinds of this drive etching facility here. One of the we call this the reactive ion etching is that one. Normally they can use that machine to etch this dielectric material, that one. And here is another very modern. This is the facility which is called this inductive coupling plasma etching system. That one is etching the semiconductor material itself. So that room we call the yellow room. The reason why it's a yellow room is they carry out the photolithography, the process. So which means in order to make this device, you have to transfer the pattern from the specific mask into the semiconductor material. And here, you can use different machine, which we call this mask annealer, to transfer the pattern from the mask, original mask, into the semiconductor material.